All right, so we have a couple of what amounts to special cases here, where we have a problem that has this division in it, and now we're trying to figure out what do I take the integral of in order to make this piece appear. Okay, as you look at it, if you took the derivative of this piece, that's the quotient rule, is it not? So that doesn't really build all that well. So just as an aside, let me just ask you this question. If I were to take the derivative of this piece, if I were to take the derivative of this piece, what would I get?
1 over 2x plus 3.
I would get what?
1 over 2x plus 3.
No. I don't get 1 over 2x plus 3. What do I get?
2x plus 3 over the original equation.
I get 2x plus 3 over the original equation, right? Because what's happening here? The ln is forcing all this to the bottom, right? The ln is forcing all this to the bottom, and then you got to take the derivative of this piece and put it on top. Does that make sense? So as we do this, what's the integral of this?
Yeah, x to the 2 plus 3x plus 4.
It's the ln of x squared plus 3x plus 4, yes? Now, where this gets hard is that as students, you can look at it after I give you the damn answer and go, oh, that's what we started with, so therefore that's got to be the answer. Oh, clear.
I'll get that on the test now.
And then there's always that one smart ass that's like, and plus C. Yeah, put the plus C in there. Don't forget that. But what do you do when I don't kind of lead you to the answer, right? Like, how do we go about doing this? And what you have to recognize is that in problems like this, where you have multiple pieces and you're trying to figure out how do you go about doing it, what you have to realize is that the derivative of one of the two pieces will be the other piece. And that, as I'm listening to it, doesn't sound very good. What do I mean? If I look at x squared plus 3x plus 4, if I take x squared plus 3x plus 4, and I say to you, what's the derivative of that piece? What do you get? 2x plus 3. What I'm saying to you is that you have two pieces, and one of these two pieces is the derivative of the other piece. Does that make sense? At least in some form. It might vary by a constant, by a multiplication factor. But the derivative of one of the pieces is the other piece. So your objective becomes, how do you identify which piece do you deal with, and then let the other piece occur via the chain rule. Does that make sense? This piece will occur via the chain rule on this piece. Does that make sense? So if I deal with this piece, I can get this piece as a ancillary part of it. Does that make sense? And that is what ultimately ends up looking like what we call U substitution. All right, so kind of today we're talking about U substitution. Okay, we're talking about U substitution, and here's the way it's going to work. What we're going to say is that that U is equal to x squared plus 3x plus 4. Right? And if I take the derivative of both sides, I get du dx, right? Because the u, if you take the derivative, this is implicit differentiation, right? There's no x there. So that becomes 1 du dx, right? Equals 2x plus 3, yes? All right. If we look at these as two separate pieces, right? Du, dx is two totally separate pieces. I want to solve for dx. So in order to do that, what would I do? I can multiply by dx, yes? Get du equals 2x plus 3 dx. Do we agree? Now, how do I solve for dx? It'd be du divided by 2x plus 3. Do we agree? Du divided by 2x plus 3. Does that make sense? So now what I want to do is I want to make two substitutions. I want to substitute this for u, and I want to substitute this for dx. All right? So how will that look? How will that look? All right? What that will look like is this. I will have, let me just restart from the original. The bottom piece goes out as a u. Do we agree? This piece goes out as what? Do we agree? Does that make sense? Okay. Now, what happens here? This, come on, you jerk. I don't want to select all of it. This and this cancel, yes? And so what does this become? It becomes the integral of 1 over u du. Do we agree? This and this cancel, and so you get du over u, which is 1 over u du. What's the integral of that? That's the one that we already talked about, right? That was the ln. You remember that? That was the one that you did earlier that you were like, oh, I think I got that one because that one's not too bad. So once we get to that point, we would say that this is equal to the ln of u plus c, right? But then what's the ln of u, which is equal to the ln of what? X squared plus 3x plus 4. Does that make sense?
How do you know what to like? Sorry, what?
Go ahead.
I was asking how come you didn't cross out the U's.
Oh, great question. Because that du is it's not, du is just the letter that we're integrating with respect to. All right, like it's like having a red car and a red truck, and you say we're going to cross out the red. No, that's not an option. All right.
Like those aren't those. The D isn't multiplying.
Yeah, the d is not multiplying by the u. It's just du is a indication of what we're taking the derivative of with respect to.
So once you get du over dx on one side, that's when you split it apart.
Mm-hmm. All right. So let's look at this one together so that you can see what we're talking about. Okay? Because this is one I don't know that you would have gotten on your own. It's it's a pretty tough problem. Do you recognize that the derivative of this piece is this piece? Do we recognize that? So what we're going to do is, with our U substitution, we're going to let U be x squared plus 5.
So that's always going to be the original.
It's always some function of the original, yes. And it's all of the original. We don't just pick out one piece. All right? We always do the whole piece. Okay? So du dx becomes what? Becomes 2x, yes? So then that makes dx to be du over 2x is equal to dx. Do we agree? Multiply this over and divide by the 2x. Does that make sense? Now, one of the I think, and math teachers, and really me on some level, I mean, if I'm being honest about it, what we're not very good at is explaining to people sometimes why we want to do something that we're doing. All right? Like, we're really good at telling you this is what you're supposed to do, but we suck butt at really sometimes explaining kind of how do you know, A, when to do it, and B, kind of why we're doing it that way. So just so that we're straight, like, to kind of really kind of hopefully put this, kind of to an understanding here, if, you jackass. I think we would all agree that if this were x to the 8th, no problem. Do we agree? And even and while I have this, even if it's not x to the 8th, right? Let's say that this is the 8th root of x. I don't like it, right? I'm not terribly fond of this whole root x thing, but yet if it were, I could write it as x to the 1/8, right? And then that would go back to that whole little, whatever you want to call it. It's kind of a power rule type deal, right? Where you add one, and then do what? Divide by it, right? So even if it were this, and again, you may not be terribly pumped on the idea of adding 1, right? But you could at least do it. Does that make sense? Where this one is x to the 9th over 9, this one would become x to the 9/8. Right? Shucks. Which is equal to x to the 9/8. Do we agree? And then you'd have to divide by 9/8, right? Does that make sense? So even if we have a radical, it's not great, but at least it's manageable. Okay? But what happens is when you get over here, you have the radical, you have this other piece attached to it, which you're not even sure how the hell you're supposed to deal with that thing, right? Like, and then the x squared, like, I don't know. Some people would be calling that x plus square root of 5. No. You can't do that. Not in this life, homie. All right, you better try that next life. All right. Can't do it that way. So we resort to this U substitution, and what does that do for me? What does that do for me? That transforms me from this problem to essentially this problem. It transforms me ultimately from this to this. Now, when I say that it transforms me from this to this, a lot of people go like this. No, that's some kind of Harry Potter shit right there. Like, that is magic. But it's not magic. Let's look. What do we have? We got this piece, yes? Well, what's x squared plus 5? That's u, yes? What's dx? du over 2x, yes? And now, 2x and 2x, what do they do? They're on top and bottom, yes? So that at that point, this 2x and this 2x will cancel, right? And what are you left with? Square root of u du. Now here's the interesting part. This is supposed to be a familiar road. You know what I'm saying? Like, if you've ever used like GPS because you damn straight lost, at some point you're supposed to get to a point where you can hit the GPS and say stop. Like, you know what I mean? Like, I got it from here, baby. Damn sure it's kind of clueless coming from Ybor City. But now that I'm in Winter Haven, we good. I don't need the directions straight all the way to my house. I just need directions to a road that I recognize. Does that make sense? This is supposed to be a road you recognize. Because from here, you would just say that this is u to the 1/2, right? Which would be u to the what? 3/2, right? 1/2 plus 1. And then what are you going to divide by? 3/2, which makes that your final answer of u to the, or 2/3, u to the 3/2. Does that make sense? When you divide by a fraction, you multiply by the reciprocal. And so you ultimately get 2/3. What's u? X squared plus 5 to the 3/2. And that is your final answer. And that is your final answer.
So you always turn the u back into whatever.
Yeah. Yeah. Always resubstitute u back after you're done. And so the whole point of the u is just to get this into one that you kind of recognize. Does that make sense? Like, that's the reason why we do the u thing, is to get this into a function that you actually recognize that you can deal with. Because let's be honest, I mean, if we're going to make a list of all the ones you know, and I'm not trying to be a jerk, okay, because the bracket's going like this. If you make a list of all the ones I know, you can stop at C. No, but realistically, which ones do you know? These are the ones you know. You know. Why does it default to 12? You know damn well that you cannot see 12. You recognize X. Like every time I try to give up cussing, like the Lord just brings me back. You recognize something to a power, right? Like that's square roots, cube roots, fourth roots, 8. You recognize some number to a power. And that's one that you can handle. Am I right? Like that's one you go like this. Oh, heck yeah, I got that. Add 1, divide by that sucker. All right? Now, which other one should you recognize? One of the other ones that you should know is e raised to the x. Because if you don't know e raised to the x, well, I'll give you a hint. It's sitting there. Right? The integral of e to the x is e to the x. So that's one that you ought to recognize. And then the only other one that you should know is 1 over x. Right? Now, a couple of semesters ago, somebody went like this. Well, if it's 1 over x squared, what happens, Dreyer? All right, now that's fair. What if it's 1 over x squared? They're like, well, is it the ln still? Nope. Why isn't 1 over x squared the ln? Because that is, no. 1 over x squared is x to the negative 2, yes? That is just like this. Add 1 and divide. Does that make sense? I can add 1 and divide. And people will say, well, do the same thing with this one. Okay. Add 1. And divide. And therein lies the problem. Does everybody see that? Therein lies the problem. Negative 1 plus 1. Now, if you look at negative 1 plus 1 and say negative 2, well, then you don't have a problem. All right? We good, baby. We teach this course again. All right? But when you get 0 on the bottom, that lies the problem, right? So as long as you have an exponent on the bottom that's not a 1, then I can deal with it using the power rule thingy. Right? Probably not a math term, power rule thingy. But you know what? Don't care.
If it works, it works.
All right? So if it's not a 1, you can use the power rule. So if this is 2, 1/2, 1/4, 3/5, 18/25, don't ask if that's an x, because I'm not going to get into what happens if it's 1 over x to the x, because that's a whole nother issue. All right? That's outside the scope of this course. Okay? Bracken, don't even worry your head about it. Just don't even, I'm sorry I even said it. All right? That's like asking your kids, like, did they catch the serial killer last night? And they're like, whoa, which girl? I mean, yeah, I'm sorry, I didn't mean to mention it. All right? Sleep well. But these are really the only 3 you can do. Something being raised to a power, e to the x, or 1 over x. Those are the only 3 you really know. And so all the problems that you get have to, on some level, look like that. Even if they don't look like that. Even if they don't look like that, they are that.
That's a weird looking answer. 1 over u to the du. I've never seen that before.
Does that make sense? So what we're going to do right now, we're going to pause and give you one to try on your own. All right? Because I know how much you love it. So we're going to pause and let you try one on your own. If you're at home, you can go ahead and pause it as well. Feel free to work this one. And we're going to do integral. Three x squared x cubed plus 7 raised to the 10th. That's the problem we're going to work together. Let's pause this and give everybody a chance to work it. All right, so, when you do this, you made the observation. It looks like to me we just ignore everything that's not in that little parenthesis right now. All right, that's not entirely accurate. All right, that's not entirely accurate. I mean, it'd be nice if that were the case, but it's not exactly accurate. So let's take a look. It's not a matter of just ignoring everything that's not in the parentheses. What we're going to do is we're going to say that u is equal to x cubed plus 7. And du is equal to 3x squared dx. All right. The dx just comes back over to the other side, okay? Now we're going to say that du over 3x squared is equal to dx, right? So now what we're going to do is we're going to take this and we're going to take this and rewrite it as, not this, we're going to rewrite it as, this piece is going to become u, right? This is going to become du over 3x squared, right? Okay. And the observation I want to make, and the reason why I want to point out that, it seems like we can just ignore everything else and just worry about this piece. Or really, I think from what I understood, you were like, screw everything else, just worry about the exponent. Right? The reason is that as long as the letters cancel, that's all I care about. Whether the numbers cancel too, that I can deal with as a coefficient. Does that make sense? Like if this were 6x squared and this were 3x squared, that's okay. Because as long as the x squareds cancel, that's what I care about. What I don't want to have happen is for this to be a 3x and this to be a 3x squared. Now I got all kinds of issues. All right, now Michael's going like this. I don't. You might have them. I don't have any issues with that. No, you have big time issues. Why? Because if that's the case, then you're going to have an extra x left over in the problem. And now you're taking the integral with respect to u, and there's an x in there, and that's all kinds of bad. All right, so when we get done, we need for at least the x's to cancel. Hopefully the numbers do too, because that just makes it easier for us. But if the numbers don't, I can deal with that. Just pull that out in front of the integral and then slap it on at the end anyway. All right?
With these problems, the exponent should always cancel.
With these problems, the x's, the variables on the outside, should always cancel. And if you don't cancel them, you've probably done something wrong. And Mitch is like, that was my point, why I just want to ignore them anyway. All right? So anyway, those cancel. This ultimately becomes integral of u du, or u to the 10th. Do we agree? This ultimately becomes what amounts to, this goes away, this is u, this is du, and now we just do u to the 11th over 11. Do we agree? And that's equal to u raised to the 11 over 11.
And then we change it back to the original one.
And then you change it back to x cubed plus 7. To the 11th over
Fraction, or you keep it,
11. Say it again?
you get rid of the 11 on the bottom, or do you?
No, it stays there.
Okay.
And then plus c, d. All right. Any questions on that? Are we sure? Let's have some fun. I'm sorry for those of you that are watching at home. We're just going to keep on going. Let's do another example. Let's go integral. We're going to go integral x e to the six x squared plus 2 dx. We're going to pause there. We're going to do the integral of x e to the 6x squared plus 2. We'll pause it there. So what did you get? I mean, who's got an answer? What'd you got?
I got e to the 6x squared plus 2 squared over 2 plus c.
Huh?
That's what I got.
All right, don't ever say that again.
Okay. Do you have to do like the du stuff and everything?
Yeah, you actually should.
I did though. I mean,
You
because like,
use the exponent, right?
because I just got e 6x squared plus 2 over 6. Is that not right?
I know.
Over 6? No.
I did everything the same way we've been doing it.
You did all of it the same way we've been doing it. All right, so let's ask. I would say to you that the derivative of this piece is functionally here. Now, it's not quite there, but it's functionally there.
Yes, I didn't see that.
Yeah, that's what I got.
All right. So we're going to let u be equal to 6x squared plus 2.
Oh, I did not do that. I thought you'd go equal to e to 6x.
Du then would be 12x dx. All right. And then we'll solve for dx. And we'll get that du over 12x is equal to dx. Do we agree? Now we'll substitute this, and we'll substitute this. Let's take a look. We got integral x e to the u. Do we agree? Now, what was dx equal to? Dx is equal to 12u over 12, or du over 12x, yes? So we'll substitute that in. Do we agree? Now, this is what I was talking to you about before. The part I'm worried about is whether or not the x's cancel. Okay? The part I'm worried about is whether or not these x's cancel. I'm not that concerned about whether or not the number cancels. Okay? Because if the number doesn't cancel, I can deal with that. If it's on top or bottom, it doesn't matter. I can deal with the number not canceling because all I got to do is all I got to do is convert that to a number outside the integral. And we'll call that EU du. Does that make sense? So if you have a number that doesn't cancel, that's cool. Just pull it in front of the radical or in front of the integral, and it doesn't matter anyway.
So it's outside the whole integral.
Yes, and then that piece will just attach at the very end. Does that make sense? That piece will just attach at the very end, and then it's all good. All right. So then again, like once you get to this point where you have E and a U, it has to be, I mean, functionally, it just has to be one of these four. It's either got to be this, it's got to be this, or it's got to be this. Right? Like it's got to be one of those four things. And in this case, we have e to the x, which we know is e to the x, right? Yes? And then, so what would this be? The final answer would be 1/12 e to the 6x squared plus 2 plus c. Does that make sense?
I put that, but I just put it over 12. It doesn't matter, right? You don't have to put it how you did.
Yes. No, you can put it over 12. It's fine.
So u is equal to 6x squared plus 2.
Yes.
So du is always the derivative of u. So it's not always just whatever. It's not just x because it's out.
No. Right. No. It's right. So du is always the derivative of whatever u is. It may or may not be the actual function that's in front of the expression.
And why? How do you know not to make e part of u? Just because.
Because if you do, then when you take the derivative of it, you're going to have to do the chain rule. The idea here is not to have to use the chain rule to take the derivative of u. Does that make sense? Like whatever I let u be, I don't want to have to make it a chain rule process.
Gotcha.
Okay? Does that make sense?
That's with everything.
Yes.
Even if it's not e. Okay.
All right, I'm going to pause the video. I'm going to stop the video here. I mean, I think I've sufficiently demonstrated that.